As far as our first talk, clearly on assessment and monitoring tools for riparian areas by Mark Petersen. He is currently owner and senior scientist of Petersen Environmental Consulting, which often contracts with Utah Farm Bureau for helping farmers and ranchers address riparian issues and sensitive species issues. And he has worked with NRCS, National Resources Conservation Service, for 32 years, and is currently the co-lead of the Utah Riparian Service team. So Mark, is Mark right there? Thanks, Mark.
Thank you. I told Mary she could say anything she wanted to, and she didn't abuse me at all. That was good. Being able to talk right after lunch and siesta time, that's a real privilege. And I was told that I should start out by humming a lullaby. But I'm not going to do that. Just give a little background. In 1996, the Bureau of Land Management and the Forest Service, in partnership with the NRCS, developed a national riparian strategy that they called the Accelerating Cooperative Riparian Restoration and Management. And this strategy, the mission of the strategy was achieve healthy streams through bringing people together. This strategy established a national riparian service team. It's an interdisciplinary, interagency team and it's based in Primeville, Oregon, and their responsibility is to coordinate the implementation of the strategy. The strategy also established a riparian coalition network. And this network is made up of riparian service teams in each of the western states, and Canada and Mexico, and Alaska as well. The network and the national team adopted as foundational tools a couple of tools to work with riparian areas in their assessment. The proper functioning condition, or PFC, which is an assessment tool, and the multiple indicator monitoring, or MIM, which is a riparian monitoring protocol. And those are what I'd like to just talk a little bit about here briefly this time. PFC stands for proper functioning condition. It's a methodology for assessing the physical functioning of riparian areas. PFC methodology provides a consistent approach for assessing the physical functionality of a riparian area. And we do this by considering hydrology, vegetation, soils, and landform. So what is it? It's developed by an ID team, an interdisciplinary team of soils, vegetation, hydrology, and biology specialists, and from the Forest Service and BLM and NRCS. And it was started developing it back in 1988. It was field tested extensively from 1990 to 1993, and then published in December of 1993. And then it was updated and published again in 1998. It can be found in this technical reference, and it's online, available, published by those three agencies. What is it? The term PFC is used to describe both the methodology, the assessment process, and a defined on-the-ground condition of riparian areas. In either case, it defines the minimum level or starting point for assessing riparian areas. It's a way to get people together to talk about and assess the riparian areas. The on-the-ground condition term refers to how well the physical processes are functioning. PFC is a state of resiliency. If an area is in proper functioning condition, there's a high probability that it'll hold together through a high flow event. It won't blow out. And it will be able to sustain the system's ability to produce the values that we all like to have from riparian areas. The assessment can provide information on whether a riparian area is physically functioning in a manner that will allow it to maintain and recover, to maintain itself or recover after an event, after a disturbance. It's not the same thing as desired condition, but it's a prerequisite to achieving desired condition, and we'll talk more about that. It's a useful tool for prioritizing restoration activities, like timing and design of restoration projects. It's a useful tool to identify situations where in-stream structures might be premature or totally shouldn't even be put there. It's not the sole methodology for assessing the health of riparian areas or terrestrial components of either the aquatic or the terrestrial components. There are other good tools as well, but this is one that we use and like. It's a very useful tool. It's not a replacement for other inventory or monitoring protocols that can give information on the biology of plants and animals that are dependent on riparian areas. It focuses on the physical functioning, physical processes and attributes of the riparian area. It's not a riparian monitoring tool. Some people have tried to use it for monitoring, but that's not what it was intended for. It's an assessment tool. However, it's a useful tool for designing monitoring. If you've done a PFC assessment, you can, you know what attributes to monitor for, where to put monitoring, which streams to monitor, and so forth. It's a qualitative assessment based on quantitative science. For every one of the elements, the discussion items in this methodology, there's a quantitative science that you can actually measure it. It's intended to be used by individuals, by an interdisciplinary team that are familiar with and experienced with how to measure the quantitative measurements and how to do that. And it's implemented using an interdisciplinary team. There's so much value to the interdisciplinary team in discussing each of these items out there in the field. And we really stress that if it's not done by an interdisciplinary team, it's not really PFC. You can use the checklist to do for communication. I do that all the time with private landowners, but it's not a PFC if I just do it myself. A definition of PFC, it has these, it has to have adequate vegetation, landform, large woody debris to do these things on this side here, dissipate energy, reduce erosion, filter sediment, and all these things that a riparian area has to do to function properly. If it's got all of these, then it can provide for improved water quality and diverse ponding and channel characteristics, habitat for fish and wildlife, production, greater biodiversity, but you need it to be able to do these things to provide this. That's kind of this is the definition of proper functioning condition. Now, this is a schematic that kind of shows the relationship of PFC to desired condition and potential natural condition. As a riparian area advances from bare ground after a big disturbance, toward potential natural condition, reaches a certain point where it can withstand a relatively high flow event without blowing it out. Down in this area, it's vulnerable. It doesn't have everything in place yet to hold itself. But after you reach PFC, then we have what we call a decision space, where you can make a decision somewhere between PFC and potential natural condition for the site, where you can manage for the values that you want in your desired condition. But PFC is a prerequisite to being able to manage for desired condition. The assessment looks at attributes with water, hydrology, soils, and vegetation, landform. We look at those attributes, all three of them. Going through PFC, there's in the field the discussion items for the interdisciplinary team to discuss and decide where we're at with each of these attributes. The floodplain. Does it have access to a floodplain in relatively frequent events? Can it access the floodplain to dissipate energy? Beaver dams, are they present, and are they, if they're supposed to be there, you have beaver dams, and are they stable so they can function properly? The sinuosity and width-depth ratio and gradient, are they in balance with what you would expect for that valley and stream type? Is the riparian area widening or diminishing? We saw some examples this morning of how they've widened. That's kind of what we're looking for here. The upland watershed, is there degradation that's being caused by some condition in the upper watershed? These are discussion items in the hydrology section. Vegetation discussion items include the composition, how do you have the right kinds of plants there? Is there recruitment of stabilizing riparian plants? Are the plants indicating the soil moisture? We're holding soil moisture. We're looking for obligate and wetland, facultative wetland plants that will indicate that we're keeping the moisture there. The water table where it should be. Root masses, plants with a root mass that can help stabilize those banks. Are they vigorous enough to do their job and for recovery and maintenance? Do we have adequate vegetation cover on the banks for functionality? And if the system needs large woody debris or large wood for dissipating energy and all that, does the riparian area plants the kind and size that can provide that to the system? And then in soils and landform, the floodplain and channel characteristics to dissipate energy. Point bars, are they revegetating as they should with riparian plants? Is the system laterally stable and vertically stable? And is the water and sediment being supplied by the watershed, is it able to process that sediment, or is there too much sediment coming in? The physical aspects of a riparian system have to be in working order to sustain the characteristics that provide for riparian resource values. It's kind of like if you build it, they'll come. You know, you got to have it properly functioning. The team goes through all of that and then discusses their yes and no answers and decides if it's in properly functioning condition, gives it a rating, meets the definition for proper functioning condition, or does it have a lot of those items there, but it is weak enough in some of them that it might be functioning, but it's at risk? Or is it just non-functional? Functioning at risk, you'll have some of those items that are weak enough that, you know, it's functioning, but there's a high probability that it'll degrade with relatively high flow events. And then non-functioning clearly lacks the elements listed. Now that was talking about moving streams. There's also a moving water, flowing water systems. There's also a protocol for lentic systems as well, wetlands. We do PFC training. We do 2-day training, and these are sponsored by the Utah Riparian team. And there's a 5-day PFC training for professionals where we really get into depth on it, training ID teams. I want to talk just a little bit about monitoring. A tool that the network has adopted is a monitoring tool. It's multiple indicator monitoring, and it's published in 2010 in this technical reference. Multiple indicator monitoring is the protocol is a methodology for monitoring use and management impacts on stream channels and riparian areas. And it's a methodology that allows statistical analysis of a comprehensive group of interrelated indicators. There are 3 short-term indicators and 7 long-term indicators. So it's a comprehensive group of indicators. That's the tech reference. The short-term indicators can be used as guidelines for grazing use, stubble height, stream bank alteration by hoof action, and woody species use. Long-term indicators that are used for monitoring the long-term trend and condition. Green line to green line, or green line vegetation composition, the woody species height, stream bank stability, green line to green line width, woody species age class, substrate particle size, and residual pool depth. Those are the long-term indicators. And you know, it takes a long time to get out to some of these sites and get a team together and get out there. And we feel like while we're out there, we might as well get more, you know, get a lot of indicators so we got a lot more information. Why these indicators? They're all measurable. There's a high rate repeatability between observers. They're applicable to the elements of functionality, and they reflect the effects of disturbance in the riparian area and channel. And they've been extensively tested for precision and accuracy. And so these are the ones that were chosen. They're done in plots that are spaced along the designated monitoring area, and within the plot we do a whole bunch of stuff, and then across the channel, the green line to green line width and substrate, and then within the channel we do the residual pool and pool frequency, and then there are 4 photo plots, there are 4 photo points that are established at each monitoring area. So it's collecting a lot of data, and it's both random and systematic. Once we've stratified and our reaches and determined where we're going to do the monitoring, then The starting point is randomly located within the reach. You lay out your designated monitoring area, put in markers both up, below and above the reach, so they're permanently marked. Take the photo points. The photo points are established, and then the first plot is randomly located as well, and then they're measured systematically along that. They're at least 110 meters long for a designated monitoring area, at least 40 plots on each side of the stream, and substrate is collected at every other one, so you have a whole bunch of samples in substrate. And as you're doing this, the data entry module tells you whether you're getting enough samples or not. And then if you don't get enough samples to be statistically sound, there's protocol as to how to add more samples. So using the plots gives us a whole lot of things that can be analyzed. And hurrying through this, you can use a field PDA to take the data with. The data entry module is there. And there's 16 automated MEM metrics in the analysis module that it automatically creates for you off from the data that's collected. So we get a lot of data and just a lot of good information that can be used in management decisions and reports and EISs and all that stuff. Do training on this protocol. We put on 4-day MEM training workshops in conjunction with the national team. And then following that, our Utah team, we do 3 to 4 day MEM implementation training following the big workshop from the national team. In these MEM implementation trainings, we go through the whole process from stratifying to the report, collecting the data, data analysis, the whole works. Training opportunities are offered by the Utah team. Just put in a little plug for that. We offer grazing management in riparian areas. We offer 1 or 2 courses in PFC each year. And we offer MEM workshops with the national team and these MEM implementation training. And we do specialized training and field trips, service trips that are done on request. If you can't put together a team, an interdisciplinary team to use these tools, there are several consultants that are available to help with that and can either help you round out a team or supply the whole team. So there you go. That's me. Mary said quit, so I had to quit. Okay. All right. She said we can do a couple of questions, if there are any. There were several people said they were going to heckle me. Where are you? Yes.
What you're interested in looking at is a little further distant, laterally away from the stream channel, is a different tool besides MIMS suggested, or can that handle plot? Is there a methodology for where you place plots laterally away from the stream?
I was wondering if there's a methodology if you wanted to get something that's further away from the stream. This is right along the green line. We do almost all of our stuff is right along the green line. There are methodologies that you can use for out away from there. We've done cross-channel transects and stuff like that, but this methodology focuses on the green line because that's where most of the disturbance takes place, is on the green line, and where the recovery has to take place for it to keep functioning properly. Any other questions? Boy, I can't see a thing with these lights in my eyes. There we go. There's one right here.
Is there a long-term database for these where you put all these studies that have been going on for a number of years now? Is all that data captured somewhere?
The national team has developed a database where these can go into, yes. And the national team keeps that. Any others?
Is that for PFC and for MIMS?
Didn't hear that. What?
Is that for both PFC and for MIMS?
They've got a MIMS database that it can go into. I don't know. Justin, are you here?
Yeah, the PFC database is just out from the National Operations Center, and it's just being tested at this point, and they're hoping to have it out by the new year for users to start.
Okay, did you hear that answer? I did. Okay, thanks, Justin. He's my co-lead in the Utah team, so he's here to answer the questions that I can't answer. All right, thank you.